Hi guys, welcome back to my mathematics tutorial. My name is Peter C. Dopper, your math tutor. I am an instructor of mathematics at the University of Liberia. So in today's lesson, we want to look at additional problems on the derivatives of exponential functions, natural exponential functions. So in the previous lesson, we solved question 1 to 7. So in this lesson, we want to solve question 8 to 13. But this one, we will solve the first three, and the next lesson, we will solve the last three. So let's begin with the first question. Question 8 says f of x is equals to e raised to the power x cubed, the ln of 3x squared. Now, we have two separate functions, a natural exponential function and a natural logarithmic function. So because we have two functions, we must apply the method called the product rule, one function being multiplied by another function. So the product rule says f prime of x, so we should hold one of the functions, so we can decide to hold the first function, and then we differentiate the second function. So the derivative of ln of a particular function is just equal to 1 over that function times the derivative of that particular function. So the derivative of 3x squared is just 6x because 2 times 3 is 6. So we're done with differentiating this one. We want to now differentiate this. So we hold ln of 3x squared and differentiate e raised to the power x cubed. So the derivative of e raised to the power u is just equal to e raised to the power u times the derivative of u. So u here is x cubed. So we first rewrite e raised to the power x cubed, and then we differentiate the power. So it's 3x squared. Now we can just simplify. So 3 into this, 1 times, 3 into 6, 2 times. This x can cancel 1 from here. You just level 1. So we now have f prime of x is equal to e raised to the power 2, e raised to the power x cubed, all over x plus. Now, don't multiply 3x squared by this argument because this is an argument for this natural logarithm. So we bring it behind. We have 3x squared e raised to the power x cubed and the ln of 3x squared. So we can figure out what is common to the both expressions. So we have f prime of x. In the numerator, we have e raised to the power x cubed. E raised to the power x cubed is common to both expressions. So we can factor it out. E raised to the power x cubed comes outside. Here is 2 over x plus 3x squared ln of 3x squared. So if you like, you want to simplify this to have one denominator, you can just find the LCD. So it's f prime of x is just equals to e raised to the power x cubed. So this now will just give us x, and it's 2 plus 1 into x is x times this numerator give us 3x cubed ln of 3x squared. Sorry, this is 3x squared. So the square is only affecting this x, not the 3. So it's 3x squared. And then all over that. So there's our final answer for that particular problem. So let's move to another problem. So question 9 says f of x is equals the square root of e raised to the power 2x plus 2x. So we can get rid of this square root. So f of x is equal to e raised to the power 2x plus 2x raised to the power 1 over 2. So this also means square root. Now let's differentiate. So f prime of x. Now we're going to use the extended power rule. So we bring this power down 1 over 2. We rewrite what is within e raised to the power 2x plus 2x. We subtract 1 from this power. So 2 times 1 is 2. So negative 2 and positive 1 is negative 1 over 2 times the derivative of what is within. So the derivative of e raised to the power 2x is e raised to the power 2x times the derivative of 2x, which is just 2, plus the derivative of 2x is just 2. So now we can have f prime of x is equal to, now this factor, we can bring this factor behind, but remember we have 2 and 2, so we can factor out 2. If we factor out 2, that 2 can cancel this 2, so it will just go out. So we just have e raised to the power 2x plus 1, because 2 had already been factored out. So 2 into this, 2 will cancel, 2 into this goes at 1 times e raised to the power 2x plus 2x raised to the power minus 1 over 2. So we can decide to make this positive by reciprocating. That is, this goes in the denominator. So we have f prime of x is equals e raised to the power 2x plus 1 all over e raised to the power 2x plus 2x raised to the power positive half. Or you can take the square root of it. So this is it. This is how we find the derivative of this function. So the next function is question 10. Y equals to e raised to the power square root of x squared minus 1. So again, we can rewrite this, or we can decide to use natural logarithm. So we can rewrite this as e raised to the power x squared minus 1 raised to the power 1 over 2, because that is it. Then we differentiate. So y prime equals e raised to any power. It's just e raised to that power times the derivative of the power. So to differentiate this power now, extended power rule, we bring this power down 1 over 2. We rewrite x squared minus 1. We subtract 1 from this power, it gives us negative 1 over 2. Then we differentiate inside. The derivative of x squared is just 2x. The derivative of 1 is 0. So this 2 can cancel this 2. So y prime now is equal to, remember now, this is negative, so it goes within the denominator as x squared minus 1. So we can just take it as square root. And then in the numerator now, we have e raised to the power x squared minus 1 raised to the power negative 1 over 2. Oh, sorry, this was not negative 1 over 2. So we just rewrite this one, and then it was here that we differentiated this power. So this is our answer. Or you can say e raised to the power square root of x squared minus 1 all over the square root of s squared minus 1. So thanks ever so much for watching. See you in our next lecture. Please don't forget to subscribe. In our next lesson, we will solve question 11, 12, and 13. Thank you.